So in this video, we're going to take a look at the individual pieces that go into making up a render story. Now, the idea is, over in the Twine project, you might have noticed that first little node, Wake Up, has a little green rocket next to it. That's the indicator that that's the first node. That's where we start from. And then, as you're playing the game, you're clicking on those hyperlinks. We're jumping around throughout the story. We are jumping from where we were to where we are now, and all we're doing is saying we are currently on this node. We click a link, we are currently on that node. We click a link, we are currently on this other node. So we're just jumping around through those individual stories. So to be able to track that kind of information, we need a few variables. Now, the way this project is going to be set up is we're going to have a couple of different strings. One to track where we currently are sitting, which heading we're currently sitting, what node we're currently sitting at. And then we're going to have another string that's going to act as kind of a lookup. It's going to act as a request. So the idea here is that if I were to hand you a book and it's closed, and I say, you are currently sitting at nothing, and you're currently not looking for any kind of page. But then if I say, turn to page 1, I'm making a request to you to open up the book and turn to page 1. If I say, go to page 5, you would then thumb through and find page 5. So that's exactly what we're going to do with this system. We're going to set up a variable that acts as our next, our intended page. And once we get to it, once we find a match, then we can say, this is our current page, and we can turn off the request. Now, for those of you who did the exercise, the day 3 exercise, you might have noticed that when we were just printing out the story bits to our console, it was just dumping a lot of text to that console. Well, doing an operation every single frame can be costly. And so oftentimes we want to build more efficient programs, make them a little bit more intelligent about the way they approach a problem. So this pattern that we're going to use for this particular project allows us to basically set up a producer-consumer relationship. We will produce a request, and then we will consume that request. And as long as there is not a new request made, we don't do any kind of actions. We're not going to send a bunch of information over to the screen text. We're not going to do that every frame. We're just going to do it the one time we're requested to do it. We'll find the page, then we'll send that information across to update our UI. The UI generally just needs a single frame's worth of update, and then you don't have to really touch it again. It's persistent, it sticks around. You only update it when you need to update it. So to do that, here inside our core file, we're going to scroll all the way up to the top to where we have our screen and book array. Now, to track this information, I want a couple of variables. The variables, I don't intend for them to be seen by the outside world, so no other potential classes can make use of them, but I do want to potentially see them just for read-only purposes. I just want to be able to visualize what's actually happening in my system. This also kind of helps with debugging. If there were any issues, I could look at what's actually being assigned as the requests and what's being set as my current location, and then I could say, well, that string's not correct. Maybe there's a typo or something like that. So it can help me debug issues if I accidentally mess something up. So to start out with, I don't want the rest of the world to see it, so I'm not going to use public, but I do want the inspector to be able to show it. So I'm going to use serialize field. So you do your square brackets, you write serialize field, and then right after that, you add the type of the variable you're working with. So in this case, it's a string. And the first item we're going to track is the current heading. So cur heading. We want another serialized field right after that. And this string is going to be called next heading. The thing is, though, when the system boots up, I actually want it to establish an initial page to turn to. I don't want to have my player do anything special. I want the book to automatically turn itself to page 1. I want it to go to the very first entry, which is what you saw over there on that Twine page. The wake up node was the one that had the green arrow. That was the starting node. That was the welcome to this game, this is what you're seeing. So instead of just saying semicolon here, I'm going to set it equal to wake up and semicolon. Now notice I'm using lowercase here, which should match, if I scroll back down, should match wake up right here. Because I'm controlling these strings, I'm responsible for making sure that all of these headings are all lowercase. So just as a sanity check, I'm going to go through, double check each one of these items and make sure that all the text across the entire thing is indeed all lowercase. And I think that wake up was the only one that had a capital W, capital U, but you know, it's usually a good idea just as a sanity check to go through and make sure that everything is indeed what you expected it to be. No surprises popping up rogue at rogue inopportune times. So at this point, we've got the ability to make the request using our next heading and the ability to say we're currently sitting at this particular page with our cur heading variable. So now we need to actually make use of that, those two variables. We need to make use of that code. So we're going to scroll back down to render story. Now down here, it's going to be after bind book, down here at the bottom. So what we want to do is ask the question, if I have seen a request from you, the player, to go to some other page, then I want to thumb through the book, all those individual pages, and I want to do a comparison. I want to say, does the page that I'm currently inspecting, does it match the request that you just made? And if it does, that's our target page. Then we'll swap out the current and next page for that particular heading. So here inside render story, the first thing I want to do is ask, did you even set next heading to a value? Well, the thing is, all of these classes that we've been dealing with so far, all the objects that we've been dealing with, integers, strings, when we create variables, if we're dealing with game objects or components or other classes like debug and that kind of stuff, if you throw a dot on those objects, you'll see that there's usually a good chunk of additional functionality listed right behind the scenes. So it turns out, and if you refer back to some of the early slides where I believe I talk about float and then I do a dot and I say max value and min value so you can see what the internal thing thinks is the maximum and minimum value of a float, you can also do that same kind of functionality off of things like the string class or some of these other classes just by throwing the dot on there. So it turns out, since we're dealing with a couple of strings, cur heading and next heading, we can actually make use of a utility method that lives inside the string class itself. So at any point, you can throw a dot on most of these objects and you're going to get a list of methods, properties, extra functionality you have access to. So in this case, the string class actually has the functionality to ask if any given string out there has been assigned or not. And it turns out a string can actually have a couple of different kind of empty values. There's not set, which is kind of like what we were talking about with our game object earlier. If you accidentally change the name of main text and GameObject.find couldn't find it, it would return you null, meaning it's an empty object. It doesn't actually exist. It was never set. Then there's, because we're dealing with strings and a string is a sequence of characters, there's the possibility that there are no characters in that sequence. It's literally a pair of double quotes with nothing in between. That is an empty string. So we can ask the string class to inspect a string variable and tell us whether or not it is null, never been set, or empty, has been set but with no content. So the idea here is inside our render story, we want to ask the question if the next heading actually has content. So the question is, coming off of the string class, if you do dot, is null or empty? That's the question. And we want to ask if next heading is null or empty. But we actually don't want to ask if it's null or empty. We want to ask if it has a value. Have you given us a value? So we need to take whatever this method returns us, which is it has content or it doesn't have content, and we need to flip it. And the way we flip a Boolean is by using the exclamation point. We use the not operator. So we put a not right there at the beginning. So if it's not null or if it's not empty, means that it has content. So we just need to ask if that's the case. So if our string is not null or empty, we can then make use of it. So finish off the if statement with our parenthesis down at the end, and then give it a body. Now the idea here is if we see a heading request, we need to look for that matching page somewhere in our array. So to do that, because you might have a 0-page book, you might have a 1,000-page book, this thing is an array, so we need to iterate over every single page. So for every page, we're going to inspect it. Well, that is a for loop. So if we do for parentheses, the initialization part, we're going to start at the very beginning. So the book is closed, or in this case, it would actually be page 1. So the 0th index, the first page, int I equals 0, semicolon. Now, the second part of the for loop is the conditional. This asks, are we still in range? Are we even allowed to run the for loop's body? Think of this section as like a miniature if statement. So the idea here is whatever I currently is, if I is less than however many pages there are in the book. So book dot length, and that'll be either true or false. If we're still within the range of all the individual pages, then it'll be true and we can run the body. If we exceed the number of pages in the book, that will be false and we'll break out of this for loop. Now the third and final portion of the for loop is the update section. So we want to take I and just increment it. So I++. And the idea here, just a quick review on for loops, is that it'll start with the initialization section, and then it says, can I even do the body? So the middle section. If this is true, it'll do the body. It'll run the code inside here. Once it finishes, it jumps up here to this update section. It updates, then it jumps back to the check section, the conditional, and it asks, now that I've updated, can I run the body again? If this is true, we run the body. Then when we finish running the body, we come up here to the update. So it basically runs as 1, 2, 3, 4, back to the update, back to the body, back to the conditional, back to the body, back to the update, back to the conditional, back to the body, and these three, conditional, body, update, conditional, body, update, continue running over and over and over and over and over again until it runs out of things that make this statement, this expression here, true. When this becomes false, the for loop ends and we tumble right off the end and continue on with the rest of our code. So the idea here is we want to look through every one of our pages until we find a match. Well, what we're actually doing is just asking the question, if that next heading that you requested earlier, if it is equal to the current page that we're looking at. So book sub I, because it's an array, but book sub I is a page. So we're going to inspect a little bit deeper by doing a dot, and now you'll notice we have the body, and a little bit further down we have the heading. So if the next heading you requested is equal to the current page's heading, then we found a match. At this point, we can throw a body on this if statement, and we can do some updates. The first thing is this is now our current heading. So cur heading set that equal to next heading. That's going to remember it. That's going to update us to that location. But now that we've processed that next heading, we need to turn off that request. We've consumed it. Now it no longer needs to exist. So on the next line, next heading, set that equal to an empty string. So 2 double quotes with nothing in between them and a semicolon at the end. That will trip the empty side of this check up here. It will be empty. So this will be true. It is empty. And true becomes false because of this not operator right here at the beginning. Meaning, if false, never runs this body. So as soon as we get to this point, we turn off that check at the very beginning. Now going back to the day 3 exercise, when we saw all that content being dumped out to the console, this is what bypasses that. We do this check, and we don't have to do that dumping information to the console. So at this point, now that we've established that we've found our proper page, our target page, we need to then actually do the updates. So we need to send the information from this page out to the screen. So we can say screen.text, set that equal to the book sub I, which is our current page, and instead of the heading from just a second ago, we're going to talk to the body. So dot body. Now just as a verification, just so we can see and make doubly sure that what we're seeing on screen is actually what's actually happening behind the scenes, we're also going to take this book sub I.body. We're going to copy that and also feed it into debug.log. Just right there, paste it in, and in that log. That way we just have a secondary printout so we can verify that we're actually seeing our information. If you accidentally, for example, one of the items on the rubric is to create play again or create a welcome screen, oftentimes people will see that and go, well, let me just throw a debug log that says welcome to my game. Well, the intent of that feature is that you add an actual page that welcomes the player to the game, not a debug log. So by doing this, by saying the screen has the same information as this debug log, you would see 2 printouts in your console, but only 1 on your screen. So that's a visual way of detecting that the information is actually updating correctly or not. If you see 2 and you only see 1 in 2 different spots, then that's oh, wait a minute, something about this is wrong. So you can, ask the question, is this what was intended? And we can tell you, no, you need to use another page to welcome the player to the game, or activate something like play again, or additional story arcs and that kind of stuff. Again, double check with the information that's over in FSO, the rubric and that kind of stuff for the actual details. And for anything not clear, reach out to your instructor and we will clarify. Okay, so at this point, we've sent the information out to the screen and we've sent the information out to the console. At this point, you're technically done with this page. The problem is, this is still inside a for loop. And if you were targeting page 1, and it's, let's say it's a 1,000-page book, you've now got 999 more pages that this thing is going to continue to for across. Well, if we found the page we're looking for, then we don't need to be inside this code anymore. We can just leave. So to get out of here, to avoid any further operations inside this whole method, what we can do is right after the debug.log, we can do a return and just get out of here. Now, if you needed to also continue working through the rest of this file, through the rest of this method, you also needed to continue working on some stuff. There are a couple of other keywords out there that allow you to do that kind of stuff. If you go looking at the documentation, you'll see the word break, which actually stops the for loop, but doesn't leave the method. And then there's another keyword out there that's continue, which allows you to skip a beat inside the for loop. So you can look up the details on those kinds of words, break and continue, and see what kind of implementation details you can use or you can leverage to make your code do some pretty interesting things. But at this point, if we found the matching page, we just want to return. We're done with this file. But there might be some kind of a weird edge case. Let's say you put a typo in there somewhere and it looped through every single page, but it never found a matching page. So what we want to do is just print out real quick that whatever was printed out here, whatever was looked for here inside the next heading, that was never found. So we would then stop what we're doing, double check our bind book, take a look at those individual settings, take a look at the upcoming code that we're going to write inside handle input, and just make sure that everything was actually correct. So any kind of typos, spelling errors, that's what would be caught in something like this. So if we reach the end of this for loop and we've not found the correct page, then we want to inform our player, very similar to, or rather, this would be for developers. The player should never see this code. The player should never see these kinds of errors or warnings. So the idea is if you're developing this app and you see this warning or this error or whatever, like the ones inside start, you would need to stop the application and figure out what happened. So in this case, when we finish this for loop, I'm actually going to get rid of that extra space that I accidentally added. And after the for loop, notice how I put my cursor on the outside of this curly or the outside of this curly up here, and it's glowing blue. That's showing you the match along this dotted line right here. So I want to put my cursor on the outside of the for loops closing curly bracket and drop down a couple of lines. Now I'm still inside the if statement's body, but I'm after the for loop. And what I want to do right here is just print out a warning that this heading was not found. Therefore, we need to just double check our code, our values, that kind of stuff. So here inside still inside the if statement, so following this dotted line all the way down, just before it ends, but after the for loop, right there, we can do a debug.log warning, and the idea is just print out heading not found. And here, I don't want to just print out the heading, because if you accidentally replace this with like the heading with like spaces or something like that, that won't be a problem up here. A bunch of spaces is not empty, and it's also not null. So we would still do this code, but a bunch of spaces would not print out correctly. You'd have to actually select the text inside the console to see that, oh, this is a bunch of spaces. So the idea here is we want to wrap up the next heading in double quotes. That way we can see whatever the value is inside those double quotes. We can actually put kind of visual formatting so we could see if it's a bunch of spaces, it'll be double quote, spaces, double quote. So there'd be no question as far as what rogue characters were injected into the system. So to do that, I need a double quote inside another string. And remember, double quotes begin and end a string, so I have to escape it. I have to use a backslash double quote. And of course here, Visual Studio is going to consume the double quote that was already sitting there. So then I have to add one more to stop the string itself. And notice how these are glowing blue, similar to what we saw with the curly brackets and parentheses and that kind of stuff. See, parentheses right there and there. And now inside the log warning, but right after that string, I want to add the next heading. And then I also want to add a closing pair of double quotes to this string so it kind of bookends the statement that we're printing out to the console. So add one more string, but inside that string use a backslash double quote. And here, Visual Studio did not consume it. So we have our string with an escaped string inside it, and then throw on the parenthesis to close it all off if it's missing, and then the semicolon at the end to stop that line. And save. So at this point, I'm going to jump over to, actually, before I do that, I have render story, but I don't actually call it. Just like with bind book, we had to call it inside start, render story has to actually be called somewhere. So if I'm updating the game, pressing buttons and that kind of stuff, it will eventually get around to the point where we have to process the next heading and see if we found a page match and then print stuff to the screen. This is going to happen pretty much every single frame, every single tick of update. So update is the candidate where render story should exist. So I'm going to scroll all the way back up here to update, and I'm going to call render story. Now I'm going to save this and jump over to Unity, let it compile, and now that we're making use of book and all that stuff, this warning should go away. And it did, but we got a new warning. Current heading is assigned but never used. Well, that's absolutely fine because we don't assign it when we very first create it up at the very top of our file, and then inside render story, all we're doing is assigning it once we find the heading match to next heading. Now we actually have to make use of it. So before we jump into what handle input is actually going to do, let's just double check and see that all of our stuff is actually correct. So our two serialized field variables now pop up over here in our game object right here in the inspector. Cur heading and next heading. Wake up was that default value. And now if I press play, by the way, if you see these kinds of warnings and that kind of stuff, ignore that. That's something inside the engine. It's not related to anything we're working on. But when you see this kind of stuff, the next heading is primed to start playing the game and jump to that next page in the book. So when I start playing, you'll see this text right here inside your game view. It will update. The console will see a printout, and over here in the inspector, this next heading value of wake up will shift into current because that will be our current heading. So let's see if that works out correctly. There you go. So wake up is now the current heading, next heading is sitting there waiting, and then we see our printout down here and our printout up here. So C is kind of emphasized right there, and F is emphasized right there. Now we'll see some other formatting here very shortly as far as how to make some of these words kind of stand out. So again, we had a new line right here to drop ourselves down, and this is just the standard word wrapping. So if you didn't like that proximity of that little mini header right there to the main body, you could throw another new line in there, you know, /n, to give yourself a little bit more space. So we'll look at some extra stuff, some formatting, some colors to actually make these letters stand out just a little bit more in a little bit. But over here in the next heading, if you were to type something in and it doesn't match, you'll notice we're getting printouts down here at the bottom. Every single time we detect a change, it comes through and it starts processing. It says, I still don't detect it. That for loop is still going to run. You still have a value here that needs to be consumed, but it never matches. And that's why this guy is sitting here just counting up, because we haven't yet found a match for ASDF. So I can get rid of that. And now that printout stops printing because we don't have a value to process. This is where debugging, either seeing information here in the inspector or seeing it here in the console, can be really useful to tracking down issues that can kind of pop up, because you're not seeing anything here in your game view, your scene view, nothing really pretty much anywhere else to indicate that there was a problem. But sometimes you can see stuff in the inspector, see stuff in the console. Maybe you have to throw a breakpoint in your code and actually attach the debugger and step through it line by line to see what's actually happening. But at this point, we're all done with the content inside render story. So now in the next video, we're going to jump in and actually construct those arrows that you saw over in the Twine file to go from node to node. That's going to be the contents of our handle input. So I shall see you in the next one.